Welcome to the 2020 Olympic Games.
On your mark, get set.
Wait! The social distance.
On your mark, get set.
Go!
And now for the 100-meter crab walk. Crab walkers, to your mark. Set. Go!
Okay.
Oh my goodness. New world record! And now for the 400-meter somersault race. Somersaulters, to your mark. Set. Go! Oh my!
Now from Kenya. Now from Switzerland.
And now from Cuba.
From North Korea. Hi, Rush, please.
From the United States of America, world record long jumper, Robert Nyson.
Let the e-learning begin. Happy Wednesday, everybody. And I just like to give a big thanks to 3 of the people in the video were our children, and the other 3 were friends and roommates of Noah's from Bethel. And you know, I just can't compete with that. A couple of them actually ran track at Bethel, and not only did they run track, they were like All-Americans in the NAIA. And one, in fact, was also All-State when he was back in high school for Northridge. And so All-State in track. You think I can compete with that? I can't compete with that. I'm telling you, those guys, they got more miles on their treadmill than I have on my car. And like, whew. And so, but rest assured, the only jogging we're going to do today is I'm going to be jogging your memory on some math ideas. And so make sure you take attendance on the form here and get that done right away. A couple of you are forgetting. You'll forget on a Friday or you'll forget on a Wednesday. And so get that done. It makes it a lot easier on me. once you get that done, we're ready to start the notes. For pre-algebra today, and so I'm going to scroll down here, we're going to kind of do two topics at once and kind of introduce both of them. We have, yes, on Monday we were finding the slope of a line between 2 points, but together we're going to be able to evaluate functions using function notation. I don't know if you ever read the little thing over here, and determine whether a function is a relation. Whether a relation is a function. Type it right, Mr. Nyson. Whether a relation is a function. And so we're going to make both those meaningful to you today. And then these things will also be reviewed when we're in algebra next year. Okay? So tonight's homework is on, not on that page. And so it's assignment number 122. These are things I got to change. Hopefully I always remember to change them. It's going to be page 388, and it's going to be 12 to 21. And then also, it's going to be on page 429, 11 to 19. And so we got 9 problems on one page. And then how many problems on that first page? Do you do 21 minus 12? Alex? No, 21 minus 11. And so, because you're not doing the first 11 problems, so that'd be 10 of them. And then make sure you're continuing working on your warm-ups and your logic problems. Some of you have already sent in your logic problems. Very good, very good. And so we have that. Okay, so but today the two topics we're going to discuss, that's our homework page, we don't want that, is function notation. And so function notation, this is notes number, what did I just say? Notes number 122. And so on function notation, we used to write it this way. X goes in, and that's called the domain or the range. What would that be, Lucas? Yes, that'd be the domain. D goes in. The domain values are your X values. So if on the homework it says, what's the domain? That's your X values. And then, Brady, what are the Y values called? Yes, it'd be the range. Home, home on the range, where the deer and the antelope play. But today, we are going to talk about X going in, and instead of saying like the function is Y equals 2X minus 5, we're going to replace, all we're going to do is the Y gets replaced with this f of X. And that is how you read it. You read this, not f times x, not f parentheses x, but we say f of x. And that is how you read that notation. Got dust in the mouse. And so this is the exact same problem. F of x equals 2x minus 5. So if X goes in, instead of Y coming out, we say F of X comes out. And so we used to have, Y equals mx plus b. And we had our slope and our y-intercept. There is no difference between that being written and us saying x plus b. It's just the way to write it using function notation. And function notation is what you're going to be using. Algebra 1, Algebra 2, pre-calculus, calculus. They just start using function notation all day long. And so the journey begins today with the first step. And some of you are like, I already knew it. Mr. Nice and I did these warm-ups on Khan Academy on Monday before you even taught it. And it's like, good job. Keep it up. And so a lot of this will just be a review on what we're doing. And so if we take a look at this and kind of move this up a little bit, if we have f of x equals 2x minus 8, f of x means that these values here are your x values. These are your domain values. These are what you're plugging in. And so if I plug in an x, we used to say a y comes out. This would be the y coordinate. But really, f of x comes out. It's what the function does to x is what comes out. And so if 8 goes in, what's going to come out? -3 goes in, what comes out? 0 goes in, what comes out? And so we just take this 8 and we don't 8 it. We plug it in. And so Josiah, what's 2 times 8 minus 5? Yes, it's 11. Next one. What do we have? Tennille, what's -3 times 2? Yes, -6. And what's -6 minus 5? Or -6 plus -5? That would be -11. Excellent. And then 0 goes in, and what comes out? Katie, 2 times 0? 0. Minus 5? -5. Now, how do we know if I didn't goof this up? Well, if 8 goes in, 11 comes out. And so we go over to 8 on the x-axis down a little bit. 8, 11 doesn't fit. So let's move. There we go. Bring back some of those numbers. So we have 8, 11, -3, -11, and 0. This is really bad. Right there, 0, -5. Now let's see if this fits. 8, 11 will be way at the top of your graph. -3, -11 would be, I'm in the way. Mr. Nyson, get out of the way. Why did I pick? You know, when we're doing these problems in class, it doesn't matter if I'm in the way. Everything fits. And then 0, -5 would be right there. And the thing is, are all of these points linear? That means they're on the same line. I forgot to finish the notes on Monday. Collinear means they all have the same slope because they're all on the same line. And so linear. And so if I connect this to those points, are they linear? Well, sure enough, they are. And what would the slope of that line be? Thomas? 2. Well, Thomas can just look over here. M is 2. But sure enough, if we graphed it, is this rising 2 every time? If you inserted all the points, well, these aren't all the points in between. These are all just the ones that have lattice points, integer coordinates. Are they all up 2 every time? Yes. And so all that's connecting. It's just a new way. Now, the hardest problem on the notes is they're going to give you the answer on 2 of them, and you have to work backwards to get the 8. And so they'll give you the 11 and say, hey, if an 11 comes out of the machine, what went into the machine? And so all you do is you set 2x minus 5 equal to 11. And if 2x minus 5 equals 11, you would add 5 to each side. Whoa, that's quite a 5 right there. You would add 5 to each side. You get 2x equals 16. And then you divide by 2, and x equals 8. And that's how you would get what goes into the machine. If they tell you what comes out, if they say f of x equals 11, what's x? That's just saying like y equals 11, and you plug it in, and you have to solve it. A little bit tougher because you got to do everything backwards. And then that's like finding the inverse, reversing the machine, okay? And so we want to take a look at that. And so we're going to do those. That's one page. And then since that's not that tough, we're going to do another page because we're running out of days, okay? So then we're going to talk about the next part. Here, we're going to determine whether a function, a relation is a function. Now, the word relation just means anything can be related. All it is a set of ordered pairs. A relation is just a set of ordered pairs, okay? Is a set of x's and y's. And you can make a set of x's and y's with anything. I could let x be everyone's length of hair, which is getting longer all the time, unless you got mom cutting your hair or something. And y could be your grade in class. And you can plot points, and it could be a function, it might not be. But in order for something to be a function, when you plug in an x, sorry about my handwriting, some days it's better than others with the mouse. Maybe if I'm trying to rush, it seems more not so good. For a function, each x only goes to only one y. When you plug in an x into the function machine, let me go get it. Whoa, almost fell out of the chair. Here we go. When you plug an x in, 3 different y's can't come out. The machine would like blow up. So if you plug in a 2, only one number comes out. You plug in a 5, only one number comes out. If I plug in a 5 and sometimes 10 comes out and sometimes negative 10 comes out, that's not a function because the machine wouldn't tell you what number to plug in. So for example, if I plug in your name and out comes your locker number. If I plug in your name and out comes your height at this moment. If I plug in your name and out comes your birthday, you only have one. And so certain things are functions. But if I plug in like your address and out comes the names of the people who live there, see, that's not a function. And so the couple questions that we're going to do, which ones are a function? I plug in the name of a month, like January, and out comes the number of days in that month. Well, Mr. Nyson, that wouldn't be a function because February sometimes has 28 days or 29 days. Well, you're right. That's why I said in 2015. And so, would that be a function, Jack? Yes, that is a function. Everything's a relation. You can relate anything to anything. And they do try to. Just listen to the news about the coronavirus. Let's relate number of cases to people's age. Let's relate number of cases to people's weight. Let's relate number of cases to your ethnicity. Let's relate, they're trying to relate anything to anything, and some of the relationships are nothing. Even if they think they got something, sometimes it's just nothing. And then they come out a week later, well, we didn't know. And so, but you relate things, and the study of functions is the beginning of that. If we plug in the address of your house, and we want the names, well, that is not a function. If we plug in your name, I say, how tall is Ainsley? You can tell me at this moment. And see, this is a function. Okay? Now, if I said, how tall is he? Well, it's changing up, but right now, plug in his name, how tall are you? That is a function. And so what we call these next things, we call them mapping diagrams. And on your homework, it's going to say, make a mapping diagram. That just means take all your domain values, your inputs, your x values, and put them in a bubble. And then put all your y values, your range values in this bubble. And then these are all arrows. And so this 2 goes to a 4. Is that a function? It only goes to one number. This 3 goes to an 8. Plug 3 in, out comes an 8. That's okay. Plug 4 in, out comes an 8. That's okay too, because 4 went in and 8 came out. Ainsley's name goes in, out comes his height. John's name comes in, maybe out comes the same height. That's okay. They don't have 2 heights, just 2 people have the same height. 5 goes in, only one number comes out. See, that is going to be a function. This is a yes. Okay? Yes. Can I write yes with arrows? Maybe I can. Yes. Interesting. Well, having a little trouble writing yes with arrows. Well, let's look at this one. 4 goes in. 7 comes out. So far, so good. 5 goes in. Right here. That's the mistake. The 5 going to the 2 and to the 9. Not good. So this one was a yes. And this one's a big old no. Not a function. Now, what would the graphs of these look like? We could take time and plot them. 5 this, 5 2, 5 9. And if you plotted 5 2 and 5 9, function. What is it? Brody? Yes, they're vertical. you can't have a point underneath another point, because that means 5 would both go to 2 and it would go to 9. I hope that's 9. If it's not, it doesn't really matter. And so it'd go to 2. So there's this thing called the vertical line test that algebra teachers all talk about. A vertical line test is a way you can look at a graph and determine whether it's a function. And so what you do is you just get yourself, pick up a vertical line. I'm sure you just got one sitting around. And so you just get yourself a vertical line like this, and then we're going to scan it. And so you start over here, and if you ever hit the graph in more than one point, it's not a function. And so we're going to scan to see if it's function healthy. And so do I ever just hit it at more than one point? See, I'm only hitting at 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. So A is a function. If I come down here to B, start scanning, oh, I hit at 1 point right when I start, but boom, I'm hitting at 2 points, up and down. And I hit it again. So see, even if at one spot it hits 2 points, it's not a function. Failed the vertical line test. We come up to C. We start in. We hit it at 1 point. 1 point, 1 point. Doesn't matter if it's discontinuous, if there's discontinuities. Those are like pre-calculus and calculus words. And we hit it just at 1 point every time. And so it's passing the vertical line test. And if we come over here to D, it hits at 1 point, but then it hits at 2 points. And then it hits at 2 points. And see, it's failing at many spots. And so this one is a yes. It's a function. This one is a big old no, not a function. And if we can begin to recognize this, that would be very good. This is yes, it's a function. And this one is a no. And again, if we didn't have the graph, see, this point would be 0, 4. And we could do this for all these points, but we'll just write 1. This is 0, 4. And this point is 0, negative 4. And see how the point 0 went to 2 different values. In a mapping diagram, 0 would be right here in my x values, or the domain values, and it would go to 4, and it would go to negative 4. And that's a big old no-no. Not a function. Not going to do it. Wouldn't be prudent. And so we don't want that. Okay? So on your homework today, let's take a look. And so on the homework, the first page is problems number 12 to 21. And so it says, copy. A relation is blank a function. So is a relation always a function? Sometimes a function or never a function? What would that be, Seth? Yes, sometimes. Relations are sometimes functions, because we just got done saying some are yes and some are no. So that's a sometimes. And then we're going to finish for 13 to 21. Notice it says represent the relation as a graph and as a mapping diagram. And then tell. So you don't have that many problems. It seems like a bunch of work. But what you want to do is, first of all, for 13, 14, 15, and 16, you only have to do it on these. These are the hardest ones. Is just make a quick graph. So draw an y-axis as an x-axis and make little marks. Or you can print off your own graph since you're on the computer all the time. And I got the sound on my face, and we don't like that. And so you make little marks. I got to be able to tell where 1, 2 is, and 2, 1, and all that. Okay? So 1, 2 is right here. 2 1's here. 3 0's here. 3 4 is here. And 4 3 is here. And that did not take that long. And is this a function? No, because this failed. So I made a graph. And then it also said next to it, make a mapping diagram. Well, a mapping diagram is you just take your x values, which is just 1, 2. You don't have to write the 3 twice. So what you would do is you would just write 1, 2, 3, 4, I declare a thumb war. And that's your x values. Then your y values are these, 2, 1, 0, 4, 3. Or you could write them in order. It doesn't really matter. 2, 1, 0, 4, 3. We're no biggie on this. That's a 0. Kind of looks like a, I don't know what it looks like. And then those are your y values. And a mapping diagram is just 1 goes to 2, make an arrow. 2 goes to 1, make an arrow. And here's the failure. 3 goes to 0 and 3 goes to 4. Not a function. And so it says, you don't have to explain your reasoning. You don't have to do that because your pictures will explain it. You could actually highlight or circle this and go, this is why it is not. Or in the graph, you can circle the part that has the 2 points vertical, one above the other. And that's why it's not. You don't have to write a paragraph. In math, your work is an explanation. And so, but you just have to bring it out so I know where to look. Because, you know, the sun's shining in and I might not be able to see very good. Okay? And so you get those 4 done. Then we have, just kind of like on the notes, is does this represent a function? Notice on 18, 19, and 20, you don't have any much work to show. Just say whether it's a function or not. Failed the vertical line test, not a function. So those are much quicker, and your homework will go a lot faster. On 21, when we talk about these basketball players, are you getting tired of watching old games on TV? But, you know, I sometimes forget what happened. You know, who won Super Bowl 51? And sometimes you forget. But this is your domain. So you could just label that domain. This is your range. There you go. Draw a mapping diagram. Well, you can do that all in the same step. Here's my mapping diagram. And then just goes. This goes to this. This goes to this. But this goes to this. But the thing is, in your mapping diagram, don't write the 82 twice because it's the same number. And then show that that goes to 2 different numbers. Not a function, not a function. And you could just go, where's my explanation? Right here. It's not a function. Okay? And then you can look at problem 22 or 21 is where we stop. But we're done with that page. And then the second page, on these, we got function f of x. If x is -1, plug it in. Then you got function g of x. Well, that means you're going to use this function. We'll plug in a 5. What does it equal? But the ones people are going to miss, the ones who don't watch to the end of the video, are 13 and 14. And 13's odd, so you can check it in the back of the book. This is saying, what did you plug in so -17 came out? And so what you do is you set -3x plus 1 equal to -17 to figure out what in the world went in to get a -17 out. So you got to subtract 1, divide by -3. Same thing here. You're going to not plug 31 in, set it equal to 31. Well, you're going to set this equal to 31. So you're going to write 10x minus 4 equals 31. And then you're going to add 4 and divide by 10. And so you might not get a whole number. That's okay. And so here you plug in -20. And this one, we'll plug in 4 to the f function, f of x. We're going to plug, this is called g of -3. We're going to plug -3 into this one. Show me what you get. And then what are we going to do with our answers, Xavier? Yes, we're going to add them. And so we'll just add our answers together. 17, 18, and 19, you just match up the graphs, okay, and you're done. You can just write ABC. So a couple of problems on that first page had a little bit of work, and you're like, no. But after that, it just was quick. And so get that done. And so we appreciate all of you that send me your homework right away. Don't be waiting around. He who hesitates is lost. And a stitch in time saves 9. Remember that. And so make sure you send me your homework, email me your questions. We miss all of you. We wish we could all be together. And so maybe sometime, hopefully soon, when all this gets back to normal. So, bye-bye. Let me know if you need anything, okay? Bye-bye.